Hello children, welcome to channel Sube. Today I am going to discuss question number 22 of 2019 Physics MCQ new syllabus paper. A celestial object is located at the midpoint of the line joining the centers of the Earth and the Moon at a certain time. The mass of the Moon is 0.0123 times the mass of the Earth. Assume that the distance between the centers of the Moon and the Earth is 60 times the radius of the Earth. The acceleration of the object due to the gravity of both the Earth and the Moon in terms of g is approximately, so there are 5 answers given. So let's draw a diagram to describe the question. Say this one is the Earth, this one is the Moon. So say radius of Earth is r, then they have given the distance is 60 times the radius of Earth between these two planets, and they say at the midpoint there is a celestial object located. Since it is the midpoint, the distances are 30r from both planets. Now let's assume the mass of Earth is capital M, simple E, capital M E, the mass of the Moon as capital M, M. What they want us to find is the acceleration of the object due to the gravity of both Earth and the Moon in terms of simple g. So the celestial object is kept here. So the acceleration, what they want, acceleration is simple g, not simple a, because this acceleration is due to gravity. We know if this one is the Earth, suppose we release a stone in the gravitational field of Earth, what is the acceleration? That is, we write as g, we don't write as a. So the same way, the acceleration what they want, so we write here what they want is simple g, but we denote it by g dash because this g dash is something different from what we write as simple g, because simple g is the acceleration at a point very close to the Earth's surface. So here we can write simple g very close to a point situated to the surface of the Earth. So that is this g, what they have given, this one is this. But this g is different from this one. Why? When we go beyond the Earth, very far away, the acceleration decreases like this. Gravitational acceleration decreases like this. Here it is 10. When the distance increases, it consequently it decreases. At this point there are two accelerations. One is given by this Moon. It is an attraction to this way, so we denote it by simple g, m. Then there's another acceleration given by this Earth to this way, that also an attraction, denote by g, Earth. So this g dash is the resultant acceleration of this one is bigger, greater, because they have given the mass is very smaller of moon. Since the mass is smaller here, the gm is also smaller. Therefore, g dash is g earth minus g moon. The direction is like this. Since this one is greater, the final direction is to this way. They don't ask the direction, so it doesn't matter. So now we have to derive this part using Newton's law. We have to find out this one. This one is the final answer. The acceleration of the object due to gravity of both Earth and the Moon. That is what they want. So that is what the thing we have to find out. It is the final answer. So now let's go to Newton's equation. F equals g m1 m2 divided by distance squared. So here g m1 is this earth, mass of earth. So what we want is, we don't want f, what we want is g earth. What is g earth? It is defined as, g is defined as force per 1 kilogram. 1 kilogram. So therefore, this m2 is now 1 kilogram. We keep an object whose mass is 1 kilogram here to find out this g. That is a test mass. Here we keep 1 kilogram. Then we find the force on that, that is simple g, because according to this definition, then force becomes simple g. Then this m2 is 1 kilogram, so this one, then divide by this distance 30 r squared. So we remove this one, it is not necessary. So the same way we can write gm equals capital G. So we now going to find out this one. So this distance we need, this mass we need g, then capital M moon, then the second one is 1 kilogram, don't have to write it. So the same distance 30 r squared. Now let's go to this equation again. G dash equals GE means capital GM earth divided by 30 r squared minus GM moon divided by 30 r squared. So 30 r squared g common, we take it out of the bracket, then me minus m moon. Now we can substitute this me we write as it is. M moon is given as this times 0.0123 times me, 1 2 3 times m earth. So what we find is final G dash. So ME is common, we take it out of the bracket, then 1 minus 0 1 2 3 divided by 30R squared. Now we subtract 10 minus 3 is 7, 9 minus 2 is 7, then 9 minus 1 is 8, then 9 minus 0 is 9. We write it here. Thirty squared, R squared separately. Then we get 30 times 30 is 900 R squared. Then we don't know this one. This one is the problem now we have. So we have to now go to this G. Let's take that part here. So let's write the Newton's equation for this G. The distance is R, F equals G m1 m2 divided by distance. So when this m2 goes to 1 kilogram, this F goes to G. So we can write G equals G m earth. So this one is 1 kilogram, this test mass 1 kilogram, therefore we don't have to write it, divided by the distance is R, this equation. We can substitute for this part. G me divided by R squared is this G. Then we write G dash, this one is G dash, equals G for this total thing, because it is equal to G, then times 0.9877 divided by 900. So we can write 987.7 times 10 power minus 3 1 2 3, right, correct, divided by 900. So this one is the final answer. Let's check the answers they have given. 1.1, 1.1, 3.3, 0.5. So these two can't be. Therefore, this must be 1.1 because this one is greater a little bit than this one. So therefore, 1.1 we don't have to divide it. Just assume like that. Looking at the answers, times G. So this G is the gravitational field strength or the acceleration what they want, not grams. This is the answer. So this one similar. So children, this one is the answer, the second one for this question. Thank you very much for watching my videos. Are you happy? If you are happy, please subscribe my channel. See you tomorrow. Goodbye.